In this video, we're going to look at topic 18, example 1, solve a system of equations by graphing. So the question is, what is the solution of the system of equations? And we're given two equations. One is y equals negative 2x minus 4. And the other one is y equals 0.5x, although I'm going to change that 0.5 to 1/2 because I want to look at the slope. So what we need to do is to find the solution by graphing. We need to graph each equation as an individual line, and then we're going to look for their intersection points. So the first equation, y equals negative 2x minus 4, we have a slope of negative 2 over 1, and we have a y-intercept of negative 4. So what we can do is we can plot that y-intercept at negative 4, and then our slope is negative 2 over 1, so we would go down 2 over 1, right, our rise and our run. All right, so we have 2 points there, and we could draw a line through them if we wanted to. I'll get to drawing the line in a second. Now, the second equation, y equals 1/2 x plus 6, we know that the slope is 1/2, and this time the y-intercept is 6, right? Because both of these are in y equals mx plus b form. So we plot the y-intercept at 6, and our slope tells us to go up 1 over 2. That goes off the graph. So instead of going up 1, right 2, I'm going to go down 1, left 2. So I'm just going to kind of reverse that process. So again, I would have 2 points, so I could draw my line if I wanted to. Now, we could just kind of connect these dots and we would be good and wouldn't really have much of a problem here. But what I do want to take a look at is I want to show how to graph these on a graphing calculator and to find the coordinate points using that. So what you want to do is, let's say we go to y equals, and this first equation, we would type in negative 2x minus 4. Now be careful when you type this in. You do want to use the negative symbol or the negative button with the 2, but you need to use the subtraction sign with the 4, otherwise you're going to run into some issues. Now what I can do, if I just hit graph, this will give me a graph of what this would look like, but what I'm more concerned with is the points, so I can go to second, and then hit graph again, and it'll bring me to a table. Now, if I scroll through this table, it'll give me a series of coordinate points. So things like negative 6, 8, negative 5, 6, negative 4, 4. And what I could do is I can plot those points using this table. And sometimes that's easier than graphing it by hand, depending on the information that they give you. And if you look at try it B, we have a y-intercept of 10, which is off of our graph. So we can't really start with that point. So it might be significantly easier if we were to type this into the calculator and pull the points from there. So I'm going to plot some of these points using the graphing calculator. I have negative 4, 4, so I can plot that right here. Negative 3, 2. So I'm not going to plot every point, but I'll go through a couple of them. Negative 2, 0, and that should be enough for now. So what I can do is I can connect these dots. And we would have our line. Try to make this as accurate as possible. Okay. And I can do the same thing for the second equation, the 1/2 x plus 6. Now, if I want to type it in the same way, I would always recommend using parentheses around any fractions, just in case. Now, you could clear the original equation, the negative 2x minus 4, or you can show them both at the same time. Just make sure you remember which one you typed in, because if I go to my table, notice how I have multiple y1s and y2, or I have a y1 and a y2. So this time, mine is obviously color-coded. You won't have that luxury with a handheld graphing calculator, but we can use this to find some more points. So I'm going to look at negative 6, 3. That would be a point, and negative 4, 4. So I can then connect these dots, and I'd have my second equation. The solution to this system is where these two lines intersect, and we see that they intersect right here, which is at the point negative 4, 4. So that point, no, let's not write that there. We'll say they intersect at negative 4, 4. So x is equal to negative 4, y is equal to positive 4. And this would be my solution. It's where those 2 points intersect. If I look at my graphing calculator, if I stay at the table, notice how if I go to negative 4, 4x. The y values are the same, which tells me that those two lines are going to intersect at that point. So for this example, I would recommend drawing this by hand or graphing this by hand because this one is quite simple. You won't really need the graphing calculator because the y-intercepts are on your graph. However, if you look at the try-it examples, again, try-it number 1b, this is off of our graph, so we can't really start with the y-intercept. I'd recommend typing that into the calculator and pulling some points from the table. The ultimate thing you're looking at here, or the main thing we're looking at here, is our solution to a system of equations is where those two lines or those two equations intersect. So in this case, -4, 4.